This is Steve Piloff from George Mason University. Let's run through a few examples with future value of annuities due. So we got the big lottery, pay out 30 equal annual installments of 10 million. First payment today. So 10 million today, 10 million in a year, 10 million in two, and if there's 30, the last one is in 29 years. The return is 5%. How much money would the winner have in 30 years if payments are placed in a trust that currently has $20 million in it? So the winner would simply have the sum of the future values of all of these 10 millions plus the future value of the 20 million. So we can approach it by saying, okay, the 20 million that's currently in there, in 30 years, it will be 20 million times 1.05 to the 30th, plus then we have all these 10 millions. There's 30 of them. We wonder how much we'll have in 30. We can find it as the future value of an annuity due, and then we can add the two pieces together. So the regular fixed payment, there's 30 of them. We're putting $10 million into our account, and we solve. We'd have 697, 607, 899. So we'd have almost 700 million. We start with 20 million, and notice the PV is negative even though we have it, because again, PV is the opposite of the present value of that. And also another way to think about it is if we're putting money in the account, we want those payments to be negative, and if we're starting with money in the account, it should have the same sign because it's working the same way to make our account bigger. And so 20 million times 1.05 to the 30th, put in 20 million, how much do we have 30 years later, an interest rate of 5%. And again, the mode doesn't matter. I forgot to note here that we're in begin mode because these 30 payments start today, first payments today, and our initial amount would compound to 86 million. Add it all up, how much did we have? 784 million. Now, remember that N has two roles. It's the number of regular fixed cash flows, and it's the number of periods from PV to FV. So, if we have a situation where we have N payments, and we have an extra cash flow or an amount, often an initial amount at time zero, we can do it in one step. If we have some extra cash flow, but it's not at time zero, you can't do it in one step. So we may have an annuity or annuity due where we have T regular fixed cash flows and we've got some extra additional contribution, but it's not at time T, then we have to do it in multiple steps. Well, this example, there's 30 payments, we don't know how much we'll have in 30 years, and we have 20 million in the account. We can do it in one step. N is 30 begin mode, put in 10 million starting today. In addition, we have 20 million in there, compounds at 5%, you solve, and you get the same result we got when we did it in two steps, because the calculator is doing all the same work, it's just doing it in one step. Now suppose the big lottery will pay 30 equal annual installments of 10 million with the first today. So we got 10, 10, 10, 10, 10, 10, 10, 10. Returns 5%. How much would you have in 30 years if you put the money in trust and an extra payment of 20 is made into the trust in 4 years? So in 40, there's 20 more in the trust. So now we're in a case where we can't do it in one step because we've got this 30 period annuity due, and the 20 million is only going to compound for 26 periods. So N is 30 for the number of payments, but N is 26 for the amount of time that the 20 million can compound. So again, you got 30 and you got 26, and again you got it as 30 minus 4, but I also think it's really important to know what's going on, so I've highlighted 4 to 5 to 6 to 7 to 8, so you can count and actually see all the 26 jumps, all the 26 periods it compounds. So what we're going to do is find the future value of the two pieces and add them up. Well, we've already seen that 10 million invested for 30 years starting today at 5%, 697 million, 608,000 roughly. Put in 20 million, compounds for 26 periods. It's very important, even though we want to know how much we'll have in 30 years, because we're putting it in 4, it only compounds for 26. So it'll compound to 71. And how much will we have in the account? $768,721,353.